Over the past few years, React has become the most popular front-end JavaScript framework. As React has matured, the open source community around React has identified areas for improvement. Since React itself is too mature to refactor completely, new projects have been started to take the best aspects of React and start from scratch. Inferno is an extremely fast React-like JavaScript library for building modern user interfaces. Dominic Gannaway is the creator of Inferno, and in this episode he joins Caleb Meredith for an interview about Inferno and other React-like JavaScript libraries. To understand how your application is performing, you need visibility into your database. VividCortex provides database monitoring for MySQL, Postgres, Redis, MongoDB, and Amazon Aurora. Database uptime, efficiency, and performance can all be measured using VividCortex. Don't let your database be a black box. Drill down into the metrics of your database with 1-second granularity. Database monitoring allows engineering teams to solve problems faster and ship better code. VividCortex uses patented algorithms to analyze and surface relevant insights so users can be proactive and fix performance problems before customers are impacted. If you have a database that you would like to monitor more closely, check out vividcortex.com/sedaily to learn more. GitHub, DigitalOcean, and Yelp all use VividCortex to understand database performance. At vividcortex.com/sedaily, you can learn more about how VividCortex works. Thanks to VividCortex for being a new sponsor of Software Engineering Daily, and check it out at vividcortex.com/sedaily.
Dominic Gannaway is the author of front-end JavaScript framework Inferno.js. Dominic, welcome to Software Engineering Daily.
Hi there, nice to meet you.
So Dominic, what is Inferno in general? Could you just give us a quick overview?
Yeah, sure. So I've been working on Inferno for maybe the last 2 years now, although mainly of that 2 years, 1 year's been taking it as an idea into a library that can be reused and play around with everybody. And it's come from a sort of collection of ideas of how to make things quicker, a bit better, a bit smaller, and take that into a library that can be consumed and I guess can be reused by lots of people. And it started off as an idea that wasn't necessarily to copy React's API or try and be a React-like library. It was just to play around with the ideas and concepts around Virtual DOM, because at the time Virtual DOM was very new. React kind of pioneered that concept into the web. And yeah, it was quite an interesting take on it. And I thought maybe we could leverage lots of ideas from Virtual DOM to try and push performance and other concepts forward in terms of how we build our apps day to day. And from there, it's been kind of a research in motion where there's lots of, spikes happening all the time, trying to come up with different things of dealing with different problems, whether that problem might be to do with mobile, or that problem to do with a particular complication in terms of how you deal with updating something on a page quick enough, or in terms of delivering faster content up on page load. Lots of different problems which I've had in my professional career that I've been able to take back into my sort of free time and apply to Inferno.
So Inferno is a front-end JavaScript framework, and a lot of people would compare it to React. So how similar is Inferno to React, like in the API layer, and maybe not perhaps in the goal layer because you touched on that already, but how similar is Inferno to React, both internally and in API?
In terms of API, they're very intentionally similar. They're meant to be similar because otherwise they wouldn't be React-like, or it wouldn't be a clone of React, you could say. But internally, they're very different in terms of how they go about dealing with different problems, in terms of how, this might get technical, but in terms of how you might diff virtual DOM from the DOM, and how you might deal with things like events, and how you might deal with going through asynchronous loops, and how you might deal with dealing with components. It's very easy to go into a very technical level without making it too technical. But the thing is, Inferno just deals with, and it tries to do things in the most simplistic way, creating the least objects possible, doing the least operations on a DOM possible, and lots of things are trying to do the least possible without making the JavaScript engine or the DOM having to deal with too much load.
So can Inferno be used as just a drop-in replacement for React in current applications built with React?
To a certain degree, I mean, you can use Inferno Compact, which is a package that's intended to be a sort of alias replacement. So you change a couple of lines in your Webpack config or your Babble RC, and then off you go. The thing is, I stress this highly, is that Inferno Compact was never meant to be a permanent fixture, and lots of people may see it that way, but it's really meant to be a sort of experimentation and an experiment to show you how compatible they could be with that sort of overhead in the middle, which is a compat layer. And the compat layer does add overhead, and it adds a significant amount of overhead too. So I don't expect to have like Inferno native performance using the compat layer. And also there are many issues and bugs that either are very difficult to fix or simply can't be fixed because of how libraries have sometimes tried to incorporate the React internals via unsupported APIs. So it makes it very difficult to try and build and fix those issues because, there's only finite amount of time I can spend on Inferno without, burning out. And that layer of compatibility does add a lot of burden to it.
Okay. So you talked about this briefly before, but why did you initially create Inferno? So the first time you opened up a text editor and started hacking on what would become Inferno, why?
So at the time I was working for a fintech company where we were building a mobile application, and we had lots of irritations and problems around performance. Maybe not initially, but over time. And we looked at different ways of dealing with it. And obviously, being in an environment where you're working with fintech or financial clients, it's very important that you make sure performance is at the highest level possible because you can't afford to make mistakes in that environment. It's not like an email client or something like that where people don't really mind if it's slow. It's where you have to be quick. So there's always the tendency to build everything with vanilla JavaScript, and libraries and frameworks tended to be pushed to a side to somewhat. So that was kind of the basis for it, working with mobile and trying to build something where other tools and libraries out there weren't quite good enough. And that's where Inferno came into play. I was not necessarily, I wasn't sure if anything would work at the time, to be fair. I just played around and experimented and saw where things led on.
So Inferno came out of a need to want to be fast on mobile. Do you think the mobile web ever will have competitive performance characteristics with native applications?
So can it be as quick as native, did you say?
Yeah. Can it ever be, and not even as quick, but just competitive?
Definitely. I mean, I think it already is competitive. I see a big audience of people who don't necessarily want to go into an app store, download 80 odd megs of data to download an app to find it, constantly pop up with updates all the time and, this, that, and the other. I think it's far more appealing to users to just go to a URL, load an app, and it just work. And you've got the added security of it, it's just like, it's hard to explain. It's kind of like that's a web page in the end of the day. People can see it as a web page, and there's this like negative aspect around native apps and how they can do things that web apps can't do with your data, with your privacy, that web apps simply won't be able to do. Well, they shouldn't be able to do. That's simply one of the benefits of the web. It won't start looking around your storage device. It won't start turning on your webcam unless you ask it to. There's no way of turning on your webcam unless you actually ask it to in a web. So all these benefits that people have just had over time, I think that's good for native and good for web, and some of the things that don't necessarily lend themselves to native. Obviously, the performance side of things are quite huge still. I mean, like there's no getting away from the fact that native is vastly quicker than web still, and there's lots of work to do there in terms of unification of terms of JavaScript itself is not necessarily the quickest language. I think we're going to see over the next year the prominence of WebAssembly and what it can bring to the table in terms of performance. especially complex computation, where JavaScript hasn't done very well in that space for a long time, and it isn't really tailored towards that sort of place to do things like that. And obviously, in a native space, that is an issue whatsoever. It's a lot more tailored towards performance. In terms of actual UIs and getting that 60 frames per second benchmark that everyone aims to get, I think the web's getting there. It's getting there closer. It's definitely not there yet, but it's only a matter of time. And there are lots of good ideas going around about how we can do that and build upon that strategy.
I definitely want to talk more about WebAssembly in a bit, but currently, as it stands, most people agree that Inferno is the fastest JavaScript front-end framework, not an accomplishment to be taken lightly, given the plethora of JavaScript front-end frameworks. What are a few of the core principles which make Inferno fast? Like a couple of the core principles you go in whenever you go to work on the code base, which make it quick.
I mean, the things performance is all dependent on what you're trying to perform against, I guess. I mean, I'd say the most important aspects are in how it deals with the DOM, in basically optimizing DOM operations, how it deals with JavaScript in terms of monomorphism and dealing with like low-level JavaScript where it can. And the third thing is trying to do sort of mid-level optimizations such as recycling and delegation and all other things that people don't necessarily do in userland code, which they could do, but Inferno kind of incorporates for them. And so like recycling could be recycling of objects, so it doesn't keep recreating objects, and recycling of DOM nodes. Lots of things like that where Inferno can kind of take over and kind of help optimize things for the user. So these things all together combine to be Inferno, I guess.
You briefly mentioned monomorphism. Could you dive in a little bit more what monomorphism is in regards to JavaScript code?
Monomorphism is actually quite a complex one to dive into, so I'll try and do it without making it sound overly complex. But it's to do with how a just-in-time compiler, or in this case, for example, like V8 or JavaScript core, takes your JavaScript code and kind of learns from it. And over time, it builds up a concept of hidden classes where you have objects and properties where the property call sites kind of link up to previous property call sites, so it can build a linkage, and that's called a hidden class. And it uses that hidden class to make low-level, not modifications, but optimizations in terms of how things are accessed and things are created and things are worked around in terms of dealing with it. And in turn, that means that lots of the operations you do in terms of JavaScript get pushed down a fast route where things are a lot quicker to access and deal with, opposed to if they weren't done that way, they'll be done in a sort of a typical JavaScript way in terms of interpretation and how things work. And I mean, the easiest way of putting it is I put an article in one of the recent JavaScript interviews I did where it explained in detail, because it's a very complex topic, and from monomorphism you go to polymorphism to megamorphism, and it does have a lot of complex topics involved in it. So I recommend reading up on it if you're interested.
Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily.
Inferno is about to hit its 1.0 release, which is an important milestone for any project. what are the big ticket items that are going to be included in the Inferno 1.0 release as of today?
So the big, I guess, features which differ from React and others will be you can do lifecycle events on functional components with Inferno, which is a huge win coming from a background where I like to use functional components. So predominantly, you've had to switch to having to use a class, whether that be a create class or ES 2015 class, to do on component mount and that sort of thing. So on component did mount, on component will mount, and all that sort of thing. So in Inferno, with functional components, you can do that explicitly via where you define the JSX. So for example, in your JSX where you have a component, you pass in it sort of like a prop to the stateless component. You pass into it, on should component update. And then Inferno will take that prop, remove it from the props because obviously you didn't mean it to be one, and apply that logic that would normally apply to classes. So you get the same benefits there. One of the benefits, improvements, I guess, features of Inferno 1.0 is that you'll have a new sort of helper class, helper logic called link event, where you can take a typical event call, say on click. You can pass through link event with the first argument being the bit of data you want to pass through, the second argument being the actual event that you want to pass through, which will be your function. And Inferno will wire up the event and the data for you. So you don't have to bind or use a closure or, other different ways of doing it. You can just use it without having to have any of that overhead. And Inferno will put it all together for you, which is really beneficial when building in a functional sense, or for those who simply don't want to keep binding functions in their constructor all the time, which can be a bit annoying. So yeah, there's that benefit. And it does give a performance benefit too. I guess the other feature is that Inferno will have, hopefully anyway, streaming of server-side rendered content on the sort of Inferno server side. So predominantly you do server-side rendering in React with render to text. Inferno, you better do render stream. So you can render to a stream, which will then provide you back an asynchronous way of passing through data to a pipe that you're basically piping through to the client, meaning the time to first byte's a lot more efficient and quicker. So you're getting data as it comes rather than waiting for the entire render to string function to be processed. Apart from the other obvious benefits of performance and lower file size, I mean, they're the main key features Inferno will have on release.
So going back to the lifecycle methods and functional components, in React and Inferno, what is the difference between a class component and a functional component? And why would React not allow lifecycle methods in functional components?
I don't think there's any reason why not. I mean, I do believe it's actually on the roadmap for the future. It's probably just a matter of prioritization in terms of adding those sort of features to React. But yeah, I don't see any big issue there.
So what is the main difference between a class component and a functional component? For those who aren't familiar.
Well, a class component has quite a bit of overhead, and it's more to type out, more to interpret, and by having a class, inherently other developers in your team might go off in a tangent and start adding lots of methods and binding this and playing around with state and all other benefits, all other things like that. With functional components, you don't have state. That's why I kind of mentioned earlier there were stateless components. But by not having state, they become a little simpler to reason with and a bit easier to test with and a bunch of other things. So having that sort of nice component that's easier to work with, where you don't have to worry about state, and it's not an element, it's not a component that you need to partially update. It becomes quite nice to work with, and having lifecycle events makes it a bit easier to do things that you previously couldn't do, like should component update, which obviously gives you big performance wins if done properly. Could be done to functional components in React. So now being able to have that means you can optimize functional components as well, which means that they're a bit less dumb, but they're still dumb in the true sense anyhow.
How has the community contributed to the 1.0 release of Inferno?
That I mean, that since maybe a month ago, or maybe a bit longer than that, maybe 6 weeks ago. I mean, I put out a post and a tweet or so, and I asked if like the community could get if I get some help from the community in terms of helping with Inferno. And the response has been overwhelmingly great. I mean, I can't say enough for all the people now working on Inferno. They've been amazing, and they've really helped at a time where I needed help, because the project has, it's been around for a while now, but it's kind of like really taken off in the last 6 months, where it became like apparent to me that it wasn't necessarily a sort of hobby. I mean, it still was a hobby, but it was like, oh, well, this is actually something that people want to use now, and it's something people value. Because for a very long time, people were saying, I don't really care for Inferno. Performance isn't my priority, and our app works fine on my perfect MacBook Pro with i7 4 cores. I don't need your library. And I was like, fair enough, that's how you feel. But I mean, I think there's been a shift in opinion, and people have started seeing that it can bring some benefits. And I'm certainly not saying to everybody, help with Inferno because Inferno is the fastest thing ever. I'm sure that lots of things in the future will outperform Inferno, and I hope they do and learn from Inferno. But lots of the people that have contributed to Inferno so far and helped building a website or improving our test coverage and adding new features and fixing lots of issues we have in the compatibility layer, we'll see that all the things they've been doing is great for the project, and I think the bigger, wider community too.
So Inferno has a Babble plugin, which does some specific compilations on a developer's JavaScript code. What specific optimizations does Inferno make in this code compilation process?
Well, it used to do a lot more, in fairness. It used to do huge amounts more, but lately it doesn't do much more at all. So I took away lots of those optimizations, and the reason was because the Inferno codebase actually took away lots of optimizations too. There used to be a concept in Inferno called blueprints, which was really quite over-engineered approach to making things quicker, which is a whole different topic. But I removed them from Inferno due to recent improvements we came up with a new idea basically, and it involved, we didn't need to do all the sort of over-engineering that blueprints introduced, meaning we could remove a lot of it from our JSX plugin. So now the JSX plugin pretty much works like a typical React plugin. And we want to expand that in the future and make it a bit more optimized. But for now, it just works pretty much the same. There's no special magic or hidden fairy dust there at all. So that's a good thing too. That plugin started to get ugly. So spaghetti code all over the place there at one stage. But now it's back to normal, and it's good and readable, and people can actually contribute to it without having a headache. So.
Could you give us a brief explanation of what the old blueprint feature did, and why at one point you thought it was would help performance, and what you ended up replacing it with?
Well, okay, so the blueprint concept was to extract static data or information from your render functions. So, for example, you'd have a huge render block, and lots of it would be static, and the idea behind blueprints was that it would pull out all the static content, and then your render would only deal with the dynamic content in terms of your JSX. So, if you had a class name that was foo, and it wasn't, a variable or an expression, it was literally foo, then that would be hoisted out to a certain degree. A bit like how the React Babble plugin currently works in terms of hoisting, but a lot more aggressive. And it would kind of clone that beforehand and do lots of like suboptimal optimizations on it. And it would mean that you would need to pass through props object literal that would be inline too, so there wouldn't be that overhead. And it kind of like made lots of little overheads, removed lots of little overheads from how it worked. The problem being was that it took that burden of all those little approaches and pushed it onto the time that the module would be loaded, because as it would hoist it out, it would be put into the scope of the module loading. So on your first time loading the app, you'd have all this overhead of all the blueprints initializing, which meant that your first time loading the app would be slower on mobile because it would be doing all this extra overhead. And the other thing that we noticed was that React apps aren't really static anymore. People just tend to literally go crazy with every bit of ES6 they can. That when I look at render functions and components, how they were built today compared to 3 years ago, they're very different. 3 years ago, people treated render functions very much like templates in the days of handlebars, and it's not like that anymore at all. So that change meant there wasn't a lot of static data there anyway. And we used loads of real-world apps that I built in the past and other people had been. And the overhead sort of performance change between the two was nothing there. But the difference in mobile load up by having like maybe 1,000 blueprints was huge. So it didn't make any sense anymore. It was kind of like, this is clearly over-engineered, and it added about 5 kilobytes of minified gzip code to the code base. So maybe about 30 kilobytes of non-gzip, non-minified code, which was quite a big amount for a library or framework. So we removed that, and it had a big benefit actually in terms of trying to aim for being simpler and being smaller.
That's a really interesting development. It's very interesting to see the discussion going back and forth of JSX versus the static templates of Angular 2 or Vue or whatever. What do you think about that? Do you still think JSX has some inherent either performance or developer experience advantages over a static handlebars template?
I don't see JSX as really being a thing. I think JSX is just another way of describing just normal JavaScript. I mean, you can take HyperScript, which is another popular, maybe not as popular as JSX, but another popular method of dealing with creating virtual DOM. It works very much the same way as create element, which what JSX compiles down to for React. I mean, it's just ways of describing how you want your view to look at a single point. And templates are doing the same thing. I don't really mind, to be honest with you. I mean, the benefit of having JSX or having pure JavaScript is that you can then let the user define how they want their view to be built using any form of JavaScript they can have their hands on. The downside being is that means that they could potentially go crazy. And I'm sure many people have seen this, and they could write terrible code, which means, it's unreadable, it's unmanageable, it's untestable, you can name it, let alone being slow. So there's that issue, and templates in a sort of old sense of handlebars and, Moustache is that they don't have that issue as much because they can put constraints in place which limit the amount of damage the user can do. So there's pros and cons of both. And obviously, when you bring constraints into the picture, you can do things quite clever with what Savelle is doing in terms of making a compile to non-framework code. Because you've got so many constraints in place, you're essentially giving a user a new DSL or a new language to learn, and that language can then be compiled into JavaScript again. I think personally we can actually work with JSX with constraints and do the same thing, but it won't be as crazy as what we have now. But we can. There is a sort of happy medium there. We can try and achieve both. It's kind of experimental for now, but there's definitely good ideas in that space of how we can do that in 2017.
All right, quickly. So for our listeners who are interested, could you just say quickly what Savelle is and where to find it? And
it's made by a friend called Rich Harris. I don't have the link on me right now as an interview, and I can't ping it over, but
that's fine. I guess just searching the name will be fine.
But it's a way of working on his previous work of Reactive, which was a framework for building UIs, and turning that into a way of getting that sort of same fundamental developer experience and pushing it over into a framework-less compiled to JavaScript bundle. Using his experience from Rollup and Babble, he's been able to obviously build something there that can mean, transferring over the least amount of data possible to build up your app, which is quite a novel idea.
How would you like to use WebAssembly to make Inferno or JavaScript apps in general even faster? You can start with Inferno, then if you want, move on to JavaScript apps in general.
I mean, I've played around with WebAssembly lately, and there's lots of work to be done there. I mean, it doesn't really fit into Inferno because Inferno aims to be like React, and I think to make WebAssembly efficient, you have to lose lots of the things that React gives you and introduce more constraints before you can actually look at that in a sort of serious manner in terms of performance and file size, etc. Because JavaScript, you can literally do anything. You can monkey patch any prototype. You can go crazy with the globals. These things aren't easy to translate into like WebAssembly, but there's definitely opportunities there to be had if you add constraints and you limit the amounts of things people can do. And you could say that's a negative thing because you're losing the JavaScript sort of way of doing things. But at the same time, you need to have an element of that before you can actually make good assumptions on how to build compiled WebAssembly code. So yeah, it's an interesting one to look into. I guess there'll be more ideas and discussions on that next year when it really takes off, I think.
So what have some of your experiments been with WebAssembly?
Well, that's not much to do with that. I mean, I looked into using type stuff, information from TypeScript and Flow, but I couldn't get much from it. I mean, the realism is you're still going to need to use duck typing because the information that TypeScript and Flow give you isn't great enough to make that compiled code go into WebAssembly because it's not low level enough. You can't infer enough information from that without duck typing. And then as soon as you start doing that, you're trying to compete against something like, a JavaScript engine itself, which is already very good at doing that. It doesn't make a lot of sense. I'd say you need to have a more formal approach to typing in JavaScript around how things are created, what types they are, because, number as a type isn't very informative. It could be any sort of type of number. I didn't find much use of that. I found it much easier to instead add duck typing to the sort of how it would compile to Rust, for example. That's one way of looking at it. But yeah, there's lots of. I'm not very good in the space of terms of that area of typing. I use TypeScript in Inferno, but yeah, there's lots of great people out there who can, go into the depths of how we could better do low-level type conversion from JavaScript to other engines.
How do you see the adoption of WebAssembly in the JavaScript community? Do you think it'll be quickly adopted, or will the JavaScript community hang on to the JavaScript?
I don't see adoption being too great at all yet. You need a whole bunch of characteristics there. You need the support of the community, the support of the browser vendors making it work, and obviously you need people to kind of give up a lot of adoption of JavaScript because WebAssembly isn't JavaScript, and all those things combined make it very unappealing to people who really love JavaScript. And I love JavaScript too, but I just like to play with new things and try new ideas. So I think it's more of a year where there'll be lots of experimentation and cool ideas coming around this kind of concept of using WebAssembly to build something React-like in the DOM. But it's way too early to say anything for sure. We've really not even entered into that sort of realm yet of building UIs from WebAssembly.
So the React core team at Facebook is currently undergoing an experimental rewrite of the React codebase, branding the new implementation as React Fiber. I don't want to dive deep into the Fiber implementation, but from a high level, what is React Fiber?
So React Fiber in its premise is a rewrite of React to take lots of the chunks of work you do in a React application and break that down into smaller chunks based off the idea of time slicing. So that work would be asynchronously done in terms of workload. So, when you hit the end of a particular event cycle, rather than continue to bloat that event cycle, it would go on to the next one and let the rest of the synchronous thread progress, meaning that you don't have any jitter on a page or any sort of jank. And it would allow the application to continue working as it would do normally, but without blocking the UI, which is a really key concept of React Fiber. And it does that by adopting a whole bunch of processes, but mainly by using its own form of stack. And that allows it to do what it does and will continue to do in terms of how it breaks down workload.
Incapsula is a cloud service that protects applications from attackers and improves performance. Incapsula sits between customer requests and your servers, and it filters traffic, preventing it from ever reaching your servers. Botnets and denial of service attacks are recognized by Incapsula and blocked. This protects your API servers and your microservices from responding to unwanted requests. To try Incapsula, go to incapsula.com/sedaily and get a month free for Software Engineering Daily listeners. Incapsula's API gives you control over the security and performance of your application, whether you have a complex microservices architecture or a WordPress site. Incapsula has a global network of 30 data centers that optimize routing and cache your content. The same network of data centers that are filtering your content for attackers are operating as a CDN and speeding up your application. To try Incapsula today, go to incapsula.com/sedaily and check it out. Thanks to Incapsula for being a new sponsor of Software Engineering Daily.
Do you think React Fiber will be faster than Inferno?
I don't know. I don't know. I mean, the thing is, they're very massively different concepts. Lots of people keep coming to me and say, look, are they the same thing? Well, they're definitely not. Inferno doesn't do any sort of asynchronous breakdown of workload like React Fiber does. It doesn't try to use things like request idle callback to break things down based on time slicing. It doesn't tend to do any of that sort of thing. And it never will do. Inferno is only meant to be synchronous. It was only meant to be an implementation of the current React, if you take it, and to push that as far as it could in making that quick. And I don't really see there being much use in rewriting Inferno to be like React Fiber. I see more of the benefits of Inferno going into React Fiber where possible. And React Fiber itself is probably going to be quicker than the current React, which is beneficial to the big user base it currently has. And in the future, I can definitely see React Fiber being as quick as Inferno, if certain things go in its favor. I mean, it's very difficult to say. It's very early days to say too, because React Fiber isn't out yet, and nor is Inferno for that matter. But we'll see maybe 6 months from now, really. I think that's a good time to choose and have a look.
So which approach, asynchronous or synchronous, do you think is better for web apps in general?
Well, asynchronous, I'd say, is always better. It depends, though. You can't compare them apples to apples. Certain things lend themselves to be synchronous, such as when you're entering data into a form, you'd expect the UI to be synchronous there. Otherwise, you get all sorts of issues. Again, you'd expect animation updates to be asynchronous because you don't want them blocking a constant loop. You need to break it down in terms of how the UI can work when you're on a single thread. And on vice versa, you want things to work synchronously when you're doing things that actually need to be performant. So when you're adding elements to the DOM very quickly, you want to make sure that all the paints and updates and recalculations happen in one event, in one time slice, or in one loop, or tick. So that happens, and you want all that to happen at once. When you break things down asynchronously, you lose a bit of that. It becomes the case where you need to do many calculation updates upon many different cycles. I'm not entirely sure off the top of my head what React Fiber does in regards to of dealing with that issue, but in my experience, that becomes quite tricky to deal with. And obviously, asynchronous code can lend itself very well for scenarios where you've got lots of things happening at once, and you need it's kind of like a race scenario where you need things to have more sort of priority than others. Where again, React Fiber deals with this, where Inferno doesn't. So there's all sorts of things that that synchronous, asynchronous lend themselves to better, and React Fiber does all of them. I believe React Fiber also happens to have priority for synchronous when you're entering data into a form. So there's that too.
Given the React core team has made it very clear that Fiber is an experimental rewrite, what do you think the chances are that the Fiber experiment fails?
I don't think it will fail. I think it's a very good idea. I mean, it depends on what you define as failure. But from what I've been told and what I've seen so far, it's been pretty successful in that they're using it currently in a very limited sense. It's all limited to the people using React Fiber at Facebook, I believe, on Facebook.com, and they're seeing it working okay. From what I gather from tweets, etc., from people on the React team. So that's a good indication that something's going right. I mean, the bigger challenge, I guess, is making React Fiber work in terms of the amounts of people out there using React libraries and frameworks and UI components and all that sort of thing, making that work with React Fiber when it previously worked with React. There might be compatibility issues, but again, it's very early days. I don't think there's been any sort of signal about that recently, so it'd be good to see how that works out in 2017.
A React core team member has complimented Inferno before by saying Inferno 1 is how they would have rewritten React, and that's incredibly high praise. So it's interesting to see them diverging in this direction. All right, so going on to the next question. There has recently been some heated discussion between framework authors and most prominently Google developer advocates when it comes to performance. By not using the native web platform and instead building abstractions, the claim is that JavaScript frameworks can seriously hurt user-perceived performance. As a framework author, what is your take on this claim?
Yeah, so I've seen that and that whole sort of like Twitter storm, tweet storm, whatever it's called. And I'd say that, there's definitely validity by both sides in terms that frameworks for a very long period of time have been doing too much and shipping too much code and really not putting the user's concerns as a priority, but rather the developer experience as a priority, when really you should be catering for both. And performance has never been like a big thing, it would seem, for many years, because there was Angular didn't perform well ever. Even if you put all the optimizations in the world into Angular, it still never performed well. Angular 2 addressed lots of those things, but it still ships a huge amount of code. And even with ahead of time compilation, you're still seeing quite a fair bit of code there. I mean, it's far more than any, typical application you use, if you're building it with Inferno, writing code to be minimalistic in terms of like a React application. I mean, there's always the case where you can easily go above that with React as well. I mean, you start putting all these third-party libraries in, especially UI libraries. People, love to pull in like Material UI and all these other different libraries, and they just add loads of bundle size to it, and they don't really gain much apart from the developer experience of building it. So there must be a good way of leveraging, tree shaking and code splitting and all these other various ideas into making this better. And this is kind of where, over the last month since these comments were made, that there's been a big push to do that. So there you can use like complex Angular applications, complex React applications, but rather you code split and you pull bits in as you need it rather than everything on one go. So rather than have one huge bundle, you break everything down into chunks. And where you come down to shipping code over to the client to make the first load or initial load, you make that as small as possible. So that's kind of where like, recent things from like Rich Harris and Savelle has come in, and also where Inferno and Preact have come in, where we're doing very little to nothing. And then you've also got other libraries like Vue, and I guess to a certain degree you've got like other sort of middleware libraries that aren't necessarily like a full-fledged framework, but they're not exactly just a Vue library too. I mean, there's a few of them out there, but I mean those libraries again kind of cater to the same degree, like Mithril, and you've got Chew, which again they don't do everything like a framework would do, but they do like in between. So it's good to see that those also dealing with the same problem. But again, it's been a big sort of tweet storm. Is this too much? Is that too little? Where do you draw the line? And I guess you just try and make it as small as possible and do lots of benchmarking, real world application tests rather than benchmarking, DB monster. You do lots of, these valid tests to try and figure out where the cutoff point is for where that's good enough. We can ship this now, and this is what our users will enjoy, and it'll work well on mobile.
Do you think web developers should eventually converge to just use the platform, or will there always be a place for frameworks?
There will always be a place for frameworks. Definitely. I can't see a reason why you'd only use a platform. Frameworks give you something that platforms never given you, is that it's something that the people in the community create. And that sort of idea of that people can build that and own it themselves without having to work for Google or Mozilla or whoever else, and they can do something that helps fix a problem that some other person has, is always going to exist. And people create things to help fix other people's problems. And as long as that sort of paradigm always exists, that's never going to change. And you can talk about, time to interactive, time to first byte, and all these other concepts of making sure the page loads quickly. But the thing is, you're always going to need frameworks or libraries out there to do this. And I guess there's maybe an idea that maybe libraries and frameworks kind of overlap. When does a library become a framework? I mean, is Inferno even a framework? I mean, I don't believe it is. I mean, so there's always that case as well. But in the end of the day, a framework is just, in my idea, it's a collection of tools that help you build an application. And, you need that regardless of what, you need it for error support, you need it for isomorphism, you need it for, if you wanted to do what React's doing now and building VR, which again is still the web, or you need it for React Native. Again, that's not the web itself, but it's an extension in many ways, and it's using the same sort of ideas. These ideas can't be done by using, web components and using the DOM. This is not there. So there's lots of things in that space that can help people work and deliver better code, and it does involve frameworks and libraries. So that's always going to exist, in my opinion.
All right. So with web components, an opinionated framework may be part of the platform in a few years. When web components arrive, will they be used instead of traditional frameworks?
I mean, I've already used web components, actually. I've got a history of using custom elements and Polymer on a previous project. And we always use that alongside another library or framework. I mean, we use Knockout, which technically isn't a framework either, but it was a way of dealing with, the UI still, and the idea of observables and that sort of ideas. I don't think you could ever do, one design idea in JavaScript, which has lots of design ideas, and say that's an application. You have a collective of lots of different design patterns and lots of different ideas to approach different problems, and they all kind of combine together to build your app. Web components are fine on their own. If you can get away with building a very minimalistic app that way, but when you start coming into lots of complex problems like routing and like server-side rendering, form validation, you could say I'll write all that in a web component, but you could also say, well, I could write a very lightweight 1 kilobyte minified gzip library that could, save me from writing 20 web components. Because this does all that in one, because it takes a level of abstraction that makes it web components ship half the amount of code. So again, web components aren't the fix to all problems, they're just part of a potential fix. And still, I've not seen any real benefits of using web components in a performant environment. For example, I've done lots of tests with Inferno, rendering and with web components, doing the exact same thing. And Inferno's outbeat them every time in terms of, initialization, in terms of doing things that you'd expect the custom elements to work really well at because they're native, but they just aren't quick. It's weird. I mean, I'm sure there's going to be lots of optimizations in that space and they'll be performing a lot better in the future, but I mean, that's a concern for somebody who's written an application in Inferno and it's running really quickly, and all of a sudden they try to go over to using, the platform as a web itself, and they're seeing a regression in performance by doing so. I mean, why would they want that for?
So thank you so much, Dominic. Thank you for your work on Inferno and for joining us today on Software Engineering Daily. Thank you so much.
No problem. Thank you very much for having the time to talk to me.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow!